Hello and welcome to another IoT Central webinar. I'm David O'Hara and I'm the Managing Director at IoT Central. I'd like to start by thanking Very for sponsoring this event. The webinar is titled Debunking IoT Myths. It's the first in a two-part series. Today's webinar will be a panel of speakers who will each introduce themselves. Starting the webinar is our moderator, Heath Marvin. He's a Senior Vice President of Engineering at Very. Heath, when you're ready, let's get started.
Thank you, David. It's nice to be here with IoT Central. I lead our engineering team here at Very. We design solutions for our clients that include UX and industrial design, cloud and app software, data science and AI, and hardware from concept all the way to production. Really everything you'd need for an IoT design. Before Very, I led product development at a company that was making IoT devices in the home security space. And prior to that, I grew up in the semiconductor industry working on connected devices really across every industry because we were serving our clients by supplying those semiconductor devices. Uma, why don't you tell us about you?
Hi guys, I'm Makran Nimalan. I lead our hardware engineering practice here at Very. We specialize in creating custom IoT appliances. And I think our call to fame is that we're very good at balancing multiple requirements and coming out with the best, or what we'd like to think is the optimal solution given those constraints. Prior to being in the client services world, I started my career out in consumer electronics, launching and mass producing, well, at scales of like million units per month. And after that, I morphed into doing R&D roles, solving specifically data center operation problems. Then once again, pivoted into InfoSec, building custom secure appliances for cloud native hardware. I'll pass it on to Steve.
Yeah, hey there. I'm Steve. I'm a lead product designer at our product design team at Very. My role revolves around crafting strategies and user experiences that not only align with our clients' vision and objectives, but also resonate with the users as well. So our focus spans UI UX design and industrial design with that solid foundation in design and user research. And one of my passions lies in exploring the intersection between hardware and software and how people and users interact with those two things. So, you know, technology is becoming a constantly more distracting thing. So I'm always looking at ways to simplify our lives rather than complicate it more. So that's a little about me. I'll hand it to Daniel.
Thank you, Steve. Yeah, I'm Daniel Fudge. I lead our data solutions practice here at Very. This extends from working with our hardware practice to deploy sensors, software algorithms, and control mechanisms to the edge, all the way through developing the software and cloud infrastructure to connect IoT devices together and to connect to the end users. My journey to IoT started in the 90s, writing computational fluid dynamics code in Fortran 77 on Cray supercomputers for aerodynamic shape optimization. From there, I kind of went to CAE and transitioned into writing aerodynamic flight models in more modern object-oriented C++ for military rotary aircraft. However, after the Columbia shuttle accident in 2003, I joined a team that extended the Canadarm with the orbiter boom sensor assembly. This was my first real introduction to hardware, which I really enjoyed. But when the shuttle program ended in 2011, I transitioned back to my roots and began building design optimization systems for jet engines at Pratt & Whitney. This rapidly led to high performance computing on the cloud, machine learning, and finally building full AI platforms. And with that, I'll pass it over to Nick.
Hey, I'm Nick Rafalo. I lead our program management department. In doing that, we ensure all projects are led using an agile methodology, with key milestones and risks being tracked and reported out on a daily cadence to our clients. My journey started in the lithium-ion battery industry, certainly not as exciting as shuttle launches, but we did launch products into production using Agile and ISO certifications and all sorts of certifications for the auto industry. But the biggest thing there was taking a product from conception to production. And that's what my background is in. So with that, I will hand it back to Heath.
Yeah, thanks everyone. Good to hear some of your backgrounds. I'm excited for what we can learn from each other together. I think probably every time we talk, we'll learn from each other and these backgrounds that we have. For those of you listening today, our goal is that no matter where you are on your IoT journey, that we can give you some insight, whether you're far along or just thinking about it for the first time. All of these panelists have been through many designs. Each new design presents new things to learn and challenges to overcome. So each time there's some new insight that we could help you see. We've all jumped into designs with misconceptions as we started that slap us in the face at some point along the way, and we hope maybe something we say today would help you avoid some of those mistakes as you're walking through your own journey into IoT. What we're going to do today is I'm going to present some myths that are believed around IoT and IoT design, and the panelists will do their best to debunk them and try to give us some of the insights that they've had as we've worked through designs together or in our prior experience. Of course, there's always more nuance than we'll be able to get to in a webinar and a forum like this. So we'd love to continue the conversation with you. You could reach out to us. As a company, Very loves to engage in these type of conversations and help people solve these problems. So we'd love to continue talking about these things. All right, let's jump into the first myth. Stated simply, we could say turning something into IoT is just adding Wi-Fi to the device. So let's talk about this from Uma's perspective on the hardware side first. The Internet of Things is just thing. So if we talk about IoT, it's a thing like a machine, sensor, or controller connected to the internet. That's the basics of what Internet of Things should be. So can we assume then creating a connected device or an IoT device is just adding Wi-Fi to it and then we're done? Uma, why don't you walk us through your thoughts on that?
Yeah, and just to put it out there, it's a possible solution. So you got to go through a bunch of processes, and you very much could end up there. And you realize all I needed was a Wi-Fi connection, I'm good to go. But generally speaking, the complexity arises because when you launch an IoT product, like any other hardware implementations, you're balancing multiple constraints, and we can bucket them into technical constraints and business constraints, right? So there's always somebody harping at you saying this cannot cost more than X number of dollars. And then you got to face the reality of your deployment situation, right? So it could be a harsh environment. There might be temperature constraints. There might be no access to power, so it has to be battery operated. It could even be at locations where there's no access to landline or even cellular services. So it's spotty services, but you are designing an IoT appliance and you need to get it to the cloud. So how do you balance these things? Let's kind of pick apart some of those requirements that I just listed out, right? Let's say we're in the business of creating node detection sensors for some sort of solar farm, right? And they want to monitor the health of the solar farms, and they want to do it remotely so that they don't have to pay expensive wages to have somebody go to this remote little town to monitor these things. So under this constraint, let's assume that where they deploy is wherever they can get land the cheapest. It also means it's probably not as densely populated, so the chances of having good LTE coverage is very low, right? So we'd go do a survey and realize we got to make trade-offs here, but we have to get these sensors online so the client can monitor it and do what they need to do and collect intelligence. Okay, so we might think maybe we have sensors that are broadcasting on a LoRa spectrum, and we have some sort of base station that has good coverage within 1,000 kilometers. Well, I want to say 1,000 meters because LoRa speculatively can do 1,000 kilometers, but it can't yet. Within 1,000-meter distance, and let's say we can get to the cloud. That might work, but now you introduce another component into the complexity of this architecture, right? So let's say the client comes back, or we ourselves realize this is way too much cost for this specific application. So we realize we need to get each of these individual units talking to the cloud, and the only way to do it with the lack of consistent cell service is to buffer the data. We collect the data find the most opportune time, and burst upload this anytime we get a good connection. Great, that's a possible solution. But because there's a solar farm, maybe it doesn't have to be battery operated. However, there's power constraints there, as well as the fact that if all of your nodes are broadcasting at the same time, you could be saturating that limited LTE bandwidth. So this is just kind of walking you through the thought processes and complexities that go into any of these. This is no different than any other development cycle. You just got to balance constraints and figure out what the optimal solution is. So you can think of it as a math homework, convex optimization problem.
Sounds like you like doing math homework.
I definitely do.
So I guess your answer was there is a case where maybe this myth is true in the sense of you just need to add Wi-Fi, but very rarely that's the case, because we start thinking about constraints of cost and battery life and wireless range and the amount of data you're sending, and suddenly that no longer is the right solution. So that's great. Thanks for that insight. Daniel, what about once we have the device to the cloud, what else has to happen besides just the hardware side?
Sure. And actually, before I jump in, I got to say, I love it when my hardware people talk about convex problems in math. So my optimization background loves that. So, but yeah, certainly once you actually start to connect, you kind of have to consider, when you're adding that connectivity, you're doing it for a reason. You're doing it to deliver value to a variety of stakeholders. This requires you to evaluate, the full data pipeline and how other users are going to interact with it. The first obvious question that comes to people is, how do you plan to ingest all this data from these devices into that cloud infrastructure? That ingestion pipeline, it's got to be robust, it's got to be secure, and it's got to be scalable. And then once the data is actually ingested, there's that full data storage, management, manipulation, and access system that must be developed. But there's actually a step that is often overlooked before that ingestion step. And that's, how do you plan to process and enrich your data on the edge before it actually reaches the cloud? Local computation allows your system to continue to operate even if a network's unavailable. That's one of the things that Uma mentioned about spotty connection. It can greatly reduce reaction times if it's critical, and it can reduce the cost of data transfer to the cloud itself. However, this impacts that hardware and network requirements that Uma mentioned previously. And too much local processing without that asynchronous backup to the cloud really limits your visibility into your system. And this visibility is critical to continue to evolve your analytics and bring more value to your users. This edge versus cloud trade has to be assessed for each application, and it may even evolve as your system starts to mature.
Thanks to you both. So Daniel, one thing you're saying, I think, is that you even have to decide where the software runs, whether it's on the device or in the cloud. Never mind some of the other things you talked about, like where to store data once it's in the cloud, security, how to process it and present it in a usable way. I think we could probably spend a whole session on any one of those pieces. But let's keep moving and talk about myth 2, since it's related to that, and I'll be coming right back to you, Daniel. So myth 2, getting data to the cloud is the hard part, kind of what we just talked about. Everything else after that is easy. So Uma talked about the hardware challenges and in even getting a device connected. And Daniel, you touched on the challenges of ingesting that data and even how to decide where to process it. Once we have the device connected and we've made those other decisions and are pushing data to the cloud, we're pretty much all set, right? That's what IoT is for. We have the data, we're good to go. Is that true?
I certainly wish everything was easy once the data reached the cloud. There's actually a classical, there we go, data, information, knowledge, wisdom, or DIKW pyramid that relates to this question. And getting the data to the cloud, that just gets you to the base of the pyramid. This raw data, it exists without any context, and by itself provides little value in isolation. The first step will be to take this data and organize it into information and describe what has happened. You'll also have to build your visualization system, present this descriptive information to your user. The next step will be to further enrich this information with meaning to provide knowledge of how and an understanding of why events occurred. And as powerful as these diagnostic capabilities are of knowledge, it's still looking backwards and it's reactive. So the top of the pyramid becomes forward-looking and proactive. You can predict then with some accuracy on what will happen. And the ultimate state is you want to be able to prescribe what actions to take to achieve your desired outcomes.
So the myth that we were just talking about really just starts us at the base of that pyramid then with data that then you have to decide how to use. That,
Absolutely.
yeah,
You can't get anywhere without the
interesting.
data, without the base, but you're just on the first level without a doubt.
Yeah. As we're talking about this, we all started thinking about AI and how AI can help us get up this pyramid. Can you talk about how this data pyramid does relate to machine learning or more generally artificial intelligence?
Yeah, absolutely. This, again, classical data pyramid really echoes what I call an analytics journey for IoT that I always like to discuss. And it really starts at that information level, and we call it descriptive. Here we can see what devices have connected, their associated telemetry, and you can use classical statistics to unlock your basic anomaly detection. However, with the growth of the volume and the variety of data, some ad hoc investigations, multi-factor analysis and visualizations, the analysis moves into this diagnostic phase that allows you to understand, again, why things happened. The next two phases hit the top of that data pyramid we had before, allowing us to deploy artificial intelligence or AI to deliver the highest value. First, we deploy machine learning to predict what will happen. And this predictive maintenance allows you to proactively service your fleet before actual failures occur. Prediction also allows you to deploy more advanced anomaly detection by detecting deviations from that expected performance. And finally, the descriptive analytics brings advanced algorithms such as reinforcement learning to prescribe what actions to take to maximize your objective function, and such as reducing your overall cost or any other key performance indicators. In general, when I tell this story, I like to say that this analytics journey is very analogous to a visit to the doctor. First, you describe what happened. So for instance, I fell down, I hurt my arm. Based on some ad hoc investigation, such as an x-ray, the doctor gives a diagnosis of a broken arm. Based on years of experience with similar cases, a doctor then will predict that it will not heal properly if it's not set effectively. So the doctor prescribes setting the bone and applying a cast so it heals quickly. So you can see there's certainly a complete journey you have to take once you get that data to the cloud.
Sure. Daniel, I want to throw another question here about just a specific example on maybe a design that you've done recently or we've been involved with around the predictive side. Like, what's a tangible example? I know we work often in the kind of industrial space with these machines that predictive maintenance is a big deal. Any specific examples there from you or someone else?
Yeah, no, absolutely. When you get into, again, IoT is a huge spectrum, many different applications, but one of the classic one is actually, machine health, and we monitor, and that's huge value, right? Again, to be able to predict when to take action. The classic way to do that is you just count cycles. And so think of your car going into get your oil changed. It's, 5,000 kilometers or 3,000 miles or whatever, wherever you may be, you're supposed to go in for an oil change. Instead of that, you then look at your system, look at a wide variety of variables and not independently, see how they operate together to be able to predict, hey, this particular unit is degrading. It may be, for instance, a vibration is one you might be picking up. There may be something in like an oil or something else that you can monitor, temperatures, speed of actuation may start to degrade. But there you take action because you're predicting that, hey, this is going to fail sooner than normal. And so you can kind of jump in and take an action before, instead of just kind of waiting for your 5,000 kilometers to come up. If you knew, and that is not only that you might go before, but it might mean that you can go well past 500 or 5,000. So you can continue to use much longer than you need to.
That's a helpful, just to tie it into a myth we'll talk about later, like how to get value quickly. That's a helpful example to think of even the basics of counting cycles. That can be an insight that can be predictive and actually bring value even without it getting more advanced into the prescriptive
and counting cycles, I'm sorry, is actually what happened. So that's at the bottom. It's descriptive. what has happened, how many cycles have occurred. That's your descriptive start.
Mhm.
Gotta need that
Mhm.
to move up to where you, until you understand
Sure.
your system more effectively.
Great. I also want to get into hearing more about how AI helps with managing data from connected devices. So we'll come back to that later because that's obviously an interesting topic. All right, now I want to move to challenges with doing the actual engineering work on a complex IoT project. Our myth 3, and I'm excited to hear from Nick on this one. As long as you have strong technical leaders in every domain, a program manager just needs to track the schedule and tasks. So Nick, you lead our program management practice. As long as we have organized and technically solid leaders in each of the disciplines that's needed for IoT, which is several different disciplines, then project management should be easy, right?
Easier said than done. I kind of relate the program manager or the product manager to a team's coach. So think about it as having a bunch of really strong players on the field. We can have the best engineers on a project, but without strategic direction, it doesn't mean we're going to win games. It's a lot like going to a kid's soccer game where a bunch of 5-year-olds playing soccer. You'll watch them facilitate the ball up and down the field, and they've got a common goal. They're going to score points, but it's not going to be effective. These guys aren't going to the World Cup. So what we try to do as program managers is try to come up with the most strategic operations in order to get clients deliverables on time, on budget, in a way that is being communicated efficiently, and the players on the field or our engineers are working together in a more harmonious direction.
It sounds like you're telling us that very engineers are like 5-year-olds playing soccer.
That's
no. So quite the opposite. They're more like World Cup players in this sense. At Very, we have chief engineers, tech leads, and technical program managers all working in conjunction. And the reason we do that is so that we could play off of each other's expertise. So obviously, Daniel, if brought onto a project as a chief engineer, or Uma, are going to have much different strategic focus than Steve as a design lead. So making sure we're playing off of everybody's roles and bringing the client's vision to life is going to drive a much more efficient timeline, and it's going to help us deliver exactly what they need. The other key attribute of the PM on our projects is to ensure that we're bringing on the right resources at the right time. So ensuring that engineers and designers are pulled into the project when it's important, and then moved off when their work is done. This helps with a couple things. It's going to help us minimize budget, but it's also going to help us maintain velocity on a project. So ensuring the team's working together and in the most harmonious direction, as well as managing resources.
The last point you made was a surprise to me at some point during my journey as an engineer and a technical leader, that you get in a big project and you wouldn't need some of the team for some amount of time because there are different pieces like hardware maybe starts and then software comes in later. And I was shocked to find out that the team wasn't just there and ready for me to start when I got to that next phase, and realized that that part of the planning was a surprising part of being successful in delivering these complex projects.
Yeah, absolutely. And, it's important for us to manage budgets just as important as timing. So
right.
each one of those.
Yeah. All right. Well, I agree with what you said, except I would say that instead of 5-year-old soccer players, I like to think of engineers as talented musicians, and the program manager is the one leading the orchestra. And just like in an orchestra, if you don't have a good conductor leading it, it will sound pretty bad no matter how world-class your engineers or your musicians are. But we won't take too much offense to your analysis. All right, we can end our first segment here. Thanks to each of the panelists and for your insights so far. In our second segment, we'll address the challenges of getting value out of IoT designs as quickly as possible. And we'll have each panelist walk us through some of the fears they've seen from our clients as they've begun their journey into IoT. I'll pass it back over to you, David.
Thanks, Heath, and thank you, gentlemen. You tackled some common myths and provided excellent insight. This concludes today's webinar. It's the first in a two-part series, so keep an eye out for part 2 coming real soon. I'd like to thank Very for their sponsorship. You can view more webinars at iotcentral.io. Thank you.